As the first applications of basic equation of a circle, we're looking at exercise 10.2 from your textbooks, which you also have a scan of. So it's exercise 10.2 on the page 253, and we're looking at example 5. It has 3 parts to it. Part A is to draw a sketch. Okay, there it was above for the beginning of lesson 6. So that can be the beginning of your lesson now, with a circle with the equation x squared plus y squared equal to 50, and the point with coordinates 6 and 3 is the midpoint of a circle. What do we know about this circle? Well, since the equation is x squared plus y squared equals to 50, I know that the center of a circle would be at the origin of the Cartesian plane at 0, 0, and the radius of this circle is square root of 50. So I will need to draw firstly a circle on the Cartesian plane, x and y. I have a circle with a center at 0, 0, and somewhere along the chord I will have this point 6, 3. Now, where will this point be? Obviously, in a first quadrant of my Cartesian plane. Secondly, if my radius is square root of 50, that means my radius is slightly more than what? What's too close to square root of 50? I've got 49, which is 7. Okay, square root of 49, so it will be between 7 and 8, because if radius will be 8, then it will be 64 under my square root. So this is the radius between 7 and 8. So if x coordinate of a point M is 6, then I obviously know it lies in the inside my circle. So 6 and 3, let's place point M somewhere here. Okay, so that's my point M, 6 and 3, and I know that this point is a midpoint of a chord. Let's call this chord AB, because it will be easier for our calculations. Okay, so more or less doesn't have to be to scale. You just want to place your circle in the correct place in a Cartesian plane and your point more or less on the Cartesian plane. They are asking us to find the gradient of OM from O to the point M, and they give us a hint. They say use the Euclidean theorem that states that OM is perpendicular to the chord. Okay, so why is OM perpendicular? Because the line drawn from a center of a circle to the midpoint of a chord is at 90 degrees to the chord. Our theory 1 of Euclidean geometry. It's a very important theory for us. We are using it not only in the Euclidean geometry, but also in the coordinate geometry. So how can I find a gradient of the line OM? Well, that should be simple, boys, because it's change in y over change in x between 2 points, 0, 0 and 6, 3. So change in y is 3 minus 0. Change in x is 6 minus 0. So the gradient of OM is a half. Okay, so sketch, find the gradient OM, and hence the gradient of a chord AB. How can I go from this gradient to the gradient of a chord AB? What do we know about AB? Well, we know that your straight line AB, which is the chord in this example, is perpendicular to the radius. Therefore, the gradient of AB must be minus 1 over this. So it must be minus 2, since for the perpendicular lines, M1 times M2 is equal to minus 1. Okay, so some theory that you are just practicing with the perpendicular lines, we also have introduced here. But here is a very important information for us, that obviously the radius of a circle will be perpendicular to the chord at the midpoint of that chord. So this is part A of this question. What's part B? Let's look. Question B is then says to us to determine the full equation of the line which is a chord. So there is a chord AB, which is a straight line, which has a gradient minus 2. So the equation will be minus 2x plus c. How to find the c? Or sub the point that lies on this line. And that's my point M with coordinates 6 and 3. So if we sub, that's my x value, that's my y value. So I've got 3 equals 2 minus 12 plus c. Therefore, c is 15. And we get that the equation of my line AB, or of the chord, is minus 2x plus 15. Okay, very simple applications. The only new part of that was the general equation of a circle. And the last part of this question was a part C. And in C, they say to determine the coordinates of P and Q, which are the points of intersection of the line and the circle. So looking at the circle again, if I had my circle and I had my chord, which we call AB, we should have called this a PQ, so we can change it, but this was our chord. We are now asked to determine the coordinates of the points of intersection of two curves. How do I find the point of intersection? Well, we used to say by making the two equations equal. Now, you will remember, boys, that I never like to say make a two equations equal, because how would you, in this case, make the two equations equal? You can't. But what we can say, and we always could say it, is that we need to solve it simultaneously. And this simultaneous set is your typical set in which one equation is a linear and one equation is quadratic. So we can substitute equation number 1 into equation number 2 and solve for x. So we have the following: x squared plus, now the y squared is minus 2x plus 15 squared is equal to 50. Okay, which means that we have the following: x squared plus 4x squared minus 60x plus 15 squared is equal to 50. Correct? You will then need to take out your calculators and set up a trinomial that we need to solve for x. And your trinomial is 5x squared minus 60x plus 175 equal to 0. So you take a 50 across and simplify. Can we simplify this trinomial further? Yes, we can. We can divide across by 5, so we get x squared minus 12x plus 35 equal to 0. Factorize either by inspection or by a use of quadratic formula. If we do it by inspection, we are looking at a 7 and a 5. Both will have to be negative. Therefore, I get x as 7 and I get x as 5. So if you look on our graph, obviously the smaller x value will be the x coordinate of P, and the larger x value will be x coordinate of Q. Okay, if we do that, how do we find the y coordinate of Q? How do we find the y coordinate of P? Well, we will substitute the x values back into equation number 1. Pause it, do the substitution, find the y values. Okay, so if x is 7, we've got minus 14 plus 5 plus 15, so we get the y coordinate as 1, and if x is 5, we've got the y coordinate as 5, okay, as we substitute here. If we want to, we can just state nicely the coordinates of P, which is 5 and the 5, and the coordinates of Q, which are then 1 and 7. And the first application of basic equation of a circle at the center 0, 0, it's done. Let's look at one more application.